Throughout this Kubernetes series, we've been creating more and more YAML files, deployments, services, ConfigMaps, secrets, Ingress resources. Every new feature adds more manifests, and as applications grow, managing all these files manually becomes difficult. Imagine deploying 10 applications, or 50, or hundreds. This is the problem Helm was created to solve. Helm helps us package Kubernetes resources together and manage them as a single application. Helm is often called the package manager for Kubernetes. The idea is very similar to tools you may already know. On Linux, we have apt. In Node.js, we have npm. In Python, we have pip. Kubernetes has Helm. Instead of manually creating deployments, services, ConfigMaps, and Ingress resources one by one, Helm allows us to install complete applications using a single command. Let's install it and see how it works. Let's install Helm locally. Once the installation finishes, we'll verify that Helm is available and ready to use. Helm Repositories work similarly to package repositories in Linux. They contain packaged applications called charts. Bitnami maintains one of the most popular Helm repositories. Let's see what applications are available. Here, Helm is querying the repository and showing matching charts. So what exactly is a chart? A Helm chart is simply an application package. Inside that package, Helm stores all the Kubernetes manifests required by the application: deployments, services, ConfigMaps, Ingress resources. Instead of managing those files individually, we install the entire package as a single unit. Let's install one now. This command installs the NGINX chart. Helm downloads the package, generates the Kubernetes manifest, and deploys everything automatically. Notice that resources already exist. We didn't manually create a deployment. We didn't manually create a service. Helm created everything for us. Every Helm installation becomes a release. Helm tracks those releases so they can be upgraded, rolled back, or removed later. One of Helm's most powerful features is customization. Most applications expose configuration options through a file called values.yaml. Instead of modifying templates directly, we simply change values. Helm then generates the final Kubernetes manifest automatically. Let's inspect the default configuration. These values control how the application will be deployed. For example, replica count controls how many pods are created. Service type controls how the application is exposed. Here, we're overriding the default value. Instead of one replica, Helm will deploy 3 pods. Notice that Helm generated a different deployment without us modifying any templates. Helm can also upgrade applications. Instead of deleting and recreating resources, Helm updates the existing release, and when we're done, Helm can remove everything it created. Deployments, services, ConfigMaps, all managed as a single application. We uninstalled the first release, my-NGINX. Notice that Helm removed the resources created by that release. But Kubernetes still has resources from my-NGINX-custom. That is because Helm tracks each installation separately. Each release has its own lifecycle. The custom release is still running with 3 replicas because we installed it as a separate release. This is important. Uninstalling one Helm release does not delete other releases. Now, Helm removed the second release as well. This is one of the main advantages of Helm. It can install, upgrade, track, and uninstall all resources that belong to an application as a single unit. Let's review what we learned. A chart is a packaged Kubernetes application. A release is an installed chart. A repository stores charts. Values allow us to customize applications. And Helm gives us a much easier way to deploy and manage Kubernetes workloads. Instead of managing dozens of YAML files manually, we can manage applications using simple Helm commands. In the next episode, we'll learn one of the most important Kubernetes skills: troubleshooting. We'll learn how to investigate broken pods, how to read logs, how to use kubectl describe, how to analyze events, and how to troubleshoot common issues such as crash loop backoff. I'll see you in the next episode.